Can you hear me? Yes, I think you can hear me now, but you don't see me. That's because you have ears. If you close your eyes and reach for the screen, you will know it's there. You feel it through your skin. If you have not been allowed to touch it, at least you can smell it. And after the hot plastic smell, you will realise that your monitor has to be there. Luckily, you have a nose. But what if you taste it? Well, it will be more difficult, but eventually you'll taste the plastic because you have a tongue. You understand the world around you, I mean everything that is around you, through those 5 senses. If you have ears, you can hear. If you have eyes, you can see. Through your skin, you can feel. The tongue will help you taste, and if you have a nose, you can smell. Eyes, ears, nose, tongue, and skin are the tools with which you were born, tools that help you understand the world around you. But how did you know all this? Just because you noticed? And how did we divide them into 5 senses? The answer is science. Because the world is so complicated, we use science to discover and define. But what is science? Investigation and study of nature by observation and reasoning, or the sum of all knowledge obtained through research. Basically, a sum of tests, numbers and letters which altogether can define. But how? Most people recognise marks as values, and the best known groups are letters and numbers. They are inventions which help us to understand our environment. To better understand how these marks came into existence, let's see a brief history of mathematics.
Human beings, from our earliest beginnings, have searched for solutions to basic problems, building homes, measuring space, keeping track of seasons, and counting objects. Over 30,000 years ago, early Paleolithic people kept track of the passing seasons and the changes of weather for planting. To represent the passing of time, they carved tally marks on cave walls or slashed tallies on bones, wood, or stone. Each tally stood for 1. But this system was awkward when it came to large amounts, so symbols were eventually created that stood for groups of objects. Sumerian clay stones have been found that date to the 4th millennium BC. A small clay cone was used for 1, a clay ball was used for 10, and a large cone stood for 60. Written records from around 3300 BC show that Babylonians inscribed amounts on clay tablets with a reed. They used a nail shape for 1s and a V on its side for 10s, combining these symbols to write other numbers. For example, Babylonians wrote the number 19 as. The ancient Egyptians used objects from their everyday life as symbols. A rod stood for 1, a cattle hobble was 10, a coiled rope was 100, a lotus flower was 1,000, and so on. The number 19 was a cattle hobble and 9 rods. The early Romans created a number system that we still see today. Along with other symbols, they used an X for 10 and an I for 1. By the Middle Ages, Romans were putting the I to the right of the X for 11 and to the left for 9. So they wrote 19 as XIX. All these creative number systems show groups of objects as well as individual objects. Some of the oldest human counting systems rely on fingers and toes, so they were based on 1s, 5s, 10s, and 20s. The Zulu word for 6 means to take the thumb of the right hand, meaning that all the fingers on the left hand had been added up and the other thumb was needed. Other systems evolved from commerce. The Yoruba in Nigeria used cowrie shells as currency and developed an amazingly complex number system. It was based on 20s and on the operations of multiplication, subtraction, and addition. For example, they thought of 45 as 3 times 20 minus 10 minus 5. Knots tied in cords and strings were used for recording amounts by many cultures, like the Persians. The Incans used a more refined version called a quipu, a thick cord held horizontally from which hung knotted string. The kind of knot the Incans used, along with the length and color of the cord, represented ones, tens, and hundreds. In today's world, almost every industrial culture uses the numerals 0 through 9. But these symbols weren't invented until the 3rd century BC in India, and it took another 800 years for the idea of zero with place value to be constructed. This big idea dramatically changed the face of mathematics. We humans have always shared with one another. When early cultures shared their food and water or wanted to divide their land in ways that were fair and equal, fractions gradually emerged as symbols for these fair share situations. The ancient Egyptians used unit fractions. Fractions where the numerator is 1, like 1/2, 1/3, and 1/5, and would add and halve these fractions. If they wanted to divide 3 loaves of bread equally among 5 family members, they'd first divide the first and second loaves into thirds. Then they'd divide the third loaf into fifths. Finally, they'd take the remaining 1/3 from the second loaf and divide that into 5 pieces. They wrote this as 1/3, 1/5, 1/15. Today, we would represent this sharing with the fraction 3/5, 3/5 of a loaf for each person, or 3 loaves divided by 5 people. The Sumerians and early Babylonians invented a number system of fractions based on 60 that we still use 4,000 years later. Our days have 60-minute hours and 60-second minutes, and our circles encompass 360 degrees. Chinese societies used an abacus with a system based on tens, although it had no zero. An early form of decimal fractions came from the abacus. For example, 3/5 would be 6 out of 10 on an abacus. The Chinese lovingly named the numerator the sun and the denominator the mother. It wasn't until the 12th century that common fractions with the bar notation that we use today were invented. Even then, these fractions weren't widely used until the Renaissance period, only 500 years ago. Throughout history, every culture around the globe has created inventive ways to calculate. To solve a problem, say 12 times 15, early Russian peasants used a system of doubling and halving. When an odd number, halved, resulted in a fraction, they rounded down. Then they added the factors associated with the odd multipliers. Ancient Egyptians relied on a doubling procedure until they produced enough groups. Then they added these groups to find the answer. Across Europe and Asia during the Middle Ages, the abacus was the handheld calculator of its day, but only very few people knew how to use it, usually wealthy merchants and moneylenders. By simply moving beads that each had place value, an abacus was a highly efficient way to compute. Then, the great Arab mathematician Al-Khwarizmi introduced the Hindu-Arabic numerals 0 through 9 into North America and Europe and created new procedures for computation. These algorithms could be written onto paper. Over the centuries, learning the algorithms became the hallmark of an education as students were taught to compute long columns of figures, borrow and carry, and do long division efficiently and reliably. They could now keep records of these procedures and check results. Today, complex calculations are done with a handheld calculator. This means students need the ability to check the reasonableness of the answer and to have a rich repertoire of mental math strategies to do that. Most simpler computations, like 12 times 15, can be solved mentally using a variety of strategies. As we journey through the rich and vibrant history of mathematics, we can see how ideas and creations grew out of our very human need to solve the problems in our everyday lives. Through time, the mathematical explorations of men and women from around the globe have given us fascinating lenses that help us to mathematically view and make sense of our worlds.
Science is the collection of facts arrived at by defining what we observe and running tests to discover. Mathematics, chemistry, and physics represent fixed languages which are not subject to interpretation. Languages used to describe what we observe and to test those observations in order to prove them. Think of DNA, cells, galaxies, fruits, laptops, air conditioning. Think about cars, food, houses, fauna, flora. Think about atoms, body parts, climate, or the clothes you wear. And realise that everything is defined or created by science. To understand the whole concept of science, you should know what a scientific theory is. A scientific theory comprises a collection of concepts, including abstractions of observable phenomena, expressed as quantifiable properties together with rules, called scientific laws, that express relationships between observations of such concepts. A scientific theory is constructed to conform to available empirical data about such observations, and is put forth as a principle or body of principles for explaining a class of phenomena. A scientific theory is totally different from any other theory. It is the most probable variant resulting from recent discoveries.
Science is the best tool ever devised for understanding how the world works.
Science is a vehicle for knowledge. We are always at the brink of the node. Science is a collaborative enterprise spanning the generations. We remember those who prepared the way, seeing through them also.
If you're scientifically literate, the world looks very different to you, and that understanding empowers you.
There's real poetry in the real world. Science is the poetry of reality.
We can do science, and with it, we can improve our lives.
There's real poetry in the real world. Science is the poetry of reality.
The story of humans is a story of ideas that shine light into dark corners.
Scientists love mysteries. They love not knowing.
I don't feel frightened by not knowing things. I think it's much more interesting.
There's a larger universal reality of which we are all a part.
The further we probe into the universe, the more remarkable are the discoveries we make.
The quest for the truth in and of itself is a story that's filled with insights.
There's real poetry in the real world. Science is the poetry of reality.
We can do science, and with it, we can improve our lives.
There's real poetry in the real world. Science is the poetry of reality.
The story of humans is a story of ideas that shine light into dark corners.
From our lonely point in the cosmos, we have, through the power of thought, been able to peer back to a brief moment after the beginning of the universe.
I think that science changes the way your mind works, to think a little more deeply about things.
Science replaces private prejudice with publicly verifiable evidence. There's real poetry in the real world. Science is the poetry of reality.
We can do science, and with it, we can improve our lives.